Here we have a couple of short trigonometry examples. One of the things you should notice is that you're very limited in the types of things that you can take antiderivatives of in the trigonometric world. We'll deal more with trig later in the course, but for right now, we're going to have a pretty limited set. In other words, the things that you can get as a result of taking derivatives of the 6 basic trig functions are the only things that we can take antiderivatives of to go back to those 6 basic trig functions. So one of the things that means is that we don't yet know how to take the antiderivative of just tangent, or just cotangent, or just secant, or just cosecant, because we don't have anything whose derivative is just any of those 4 things. So please be very careful with the trig stuff. In the first problem we have here, we just have the cosine and sine, and we know how to deal with those pretty well. The antiderivative of cosine is going to be sine, so this is going to be sine of x, minus the antiderivative of sine is negative cosine. So notice that I'm being careful with my negatives there. So I'm going to end up with sine of x minus, that first minus comes from the integrand, and then end up negative cosine x because that's the antiderivative of sine of x. And of course we have our constant of integration. And we can clean that up a little bit, and we can write it as sine of x plus cosine of x plus c. And if we chose to take the derivative of that, we would end up right back where we started. The second one doesn't look like any of the rules that you have other than the fact that it has sine of theta and cosine of theta in it. But the cosine squared, and we don't have any way to deal with cosine trig function squared yet. We also have a quotient rule. We don't have any way to deal with the quotient rule yet. So our most likely avenue to finding this antiderivative is using our trigonometric identities to see how we can rewrite it. So what I'm going to do is I'm going to choose to write this as the antiderivative of 1 over cosine of theta times the sine of theta over the cosine of theta. Now why did I choose that? Well, I chose that because I've had a lot of practice working with these trig identities, and that's something that just the more practice you get, the better you get at trying to split these things up. The reason I've split these up this way is because I'll end up with secant of theta, that's the first part, 1 over cosine of theta, times the tangent of theta, sine theta over cosine theta, d theta. And if we look at our list of rules, we'll find that that has an antiderivative of secant of theta. Oops, don't need the antiderivative symbol there anymore. And of course we'll have our constant of integration. Derivative of secant theta is secant theta tangent theta. Secant theta tangent theta can be rewritten in terms of cosine theta and sine theta as sine theta over cosine squared theta. You won't get a lot of these in your web assigns, but you should be able to take a look at these and work with them when you do come across them.